Welcome back to Base Angle Theorem. In this podcast, we're going to do just two problems. All right, so we want to solve for A, S, and K. I believe this problem is in your notes. It's very similar to some problems on your weekly work. I want you to write what I have written in blue there. In isosceles triangles, angle bisector to the base is a perpendicular bisector. Now, what does that mean? All right, well, so remember how we proved that base angles were congruent, right? Well, it's hard to see. It's even two angle markings. I'll use the alternate method, which is to put a line there so you can see the two angles. There we go. All right, so remember we were able to prove the base angles were congruent using an angle bisector, right, dividing into two triangles. Well, in an isosceles triangle, our altitude, which is the same as our height, remember altitude is always perpendicular to the base, and that angle bisector is the altitude or height. They are the exact same thing. So we know that height, altitude, has to be, actually I'll write altitude with height. Altitude with parentheses height, so that you know that they're referring to really the same thing. Altitude is the correct way to represent that, but sometimes we just call it height. All right, so this angle bisector is also the altitude, which means, why I'm mentioning this now, it's perpendicular to the base because the altitude is always perpendicular to the base. So I have to tell you that because, well, it's important information, and it lets us know that A is 90 degrees. Okay? So anytime you have an isosceles triangle, right, two sides congruent, the altitude is always perpendicular to the base, right? And so it's going to bisect the angles. It's going to create two congruent triangles. And it's going to, of course, because it has to be perpendicular to the base, going to create 90-degree angles on either side of that altitude, right? So I just wanted to point that out. So isosceles triangles are great triangles to work with, right? So S, right? So here we know this is 90 because the angle bisector is perpendicular to the base in isosceles triangles. Just want to make sure it was really, really clear. So we wrote it 4 times. No, 3 times. All right, so S, that's got to be 68 degrees. Right, we're just using, actually I better put 2 markings here. We're just using base angle theorem. And then last but not least, K. Right, so remember that this altitude here, because it's an isosceles triangle, right, we proved the base angle theorem by proving the two triangles are congruent. Going back the other direction, that angle bisector, because these two triangles are congruent, right, is going to divide that base into 2 congruent parts. Right? So if this, I have to outline it, if this much is 16, then so is K. So K is equal to 16 because the angle bisector divides an isosceles triangle into 2 congruent triangles is one way to think of that. All right. Or you can think of it as a perpendicular bisector. So we'll write that as well. It happens to be a perpendicular bisector. So that altitude does a lot of things. All right, one problem done. This one was, I think, it was easy. We didn't have to do any solving, but it uses more reasons and definitions than any of the other problems have used, I think. I think the last problem on the first podcast was the most tricky. But if any part's not making sense, remember, you ask, and I'll go over it with you again. It even says it right here. Ask if you have a question. All right, last problem. Told you this was going to be a short podcast. We're going to find the values of x and y in the diagram. So we've been working just with angles. Let's work with some sides. Hopefully, the first thing you look at is which variable is easier to solve for. And as soon as you see you have 3 angles congruent, remember, if a triangle is equiangular, it is equilateral. Right? And that's just part of, yeah, we got our T's crossed, and that's just part of base angle theorem. So that means y equals 4. And then the other part is also base angle theorem. And that is, and actually this actually isn't base angle theorem. I should be more specific. It's related to base angle theorem. It's just going the other way. It's the converse of base angle theorem. We should be specific. I should be specific. Converse of base angle theorem. Because we're going the other way. We're going from angles to sides, as opposed to sides to angles. So again, we're going to use the converse of the base angle theorem in the second part here, and that is that sides opposite congruent angles in a triangle are congruent. And again, we're not going to write it again. That just goes back to base angle theorem as well. So the converse of base angle theorem. So that means that these, because you might be thinking, okay, but yeah, what am I going to use to solve? Right? I don't know the other side. I only know one side in the triangle. Or do you? Right? So we know y is 4. All the sides are 4. Every one of them is 4. Lots of 4s. I'll write it in 4, and this is 4. So that means that x plus 1 is equal to 4. And if we subtract 1 from both sides, x is 3. And there you go. So the solving was really easy. You just had to know how to set it up. And you will have some problems like this in your weekly work. That's the end of my podcast. And that's the end of this lesson on base angle theorem. So thanks for watching, and bye for now.